Hi, my name is Andrea, and today I'm going to be going through day 15 from the 30 Days of Code challenge on HackerRank.com. If you are unfamiliar with the challenge, I welcome you to check out this website. It's a great resource for practicing your coding skills. Today we're going to be going over linked list, and I'm going to be coding in Python. I'm going to assume that you've already read through the problem and that you're pretty familiar with linked lists, but just in case you need a quick refresher, I'm going to go through that very briefly. All right, so HackerRank is really good when they have the challenges. The documentation is very thorough. The task is very clearly defined. A lot of the time, it's mostly an exercise in learning how to figure out what they want. The code itself is often not the hardest part. So linked lists, what are they? Real quickly, a collection of nodes. And a node has two pieces of information that comes with it. A node has its current node's data. It can be an integer, it can be text, it can be anything. It's just whatever data you want to have stored in that node, and then a pointer, which is going to point to the next node in the sequence. When you have a traditional regular list, right, like this one up here, 2, 3, 4, 1, it's a list. It is in sequence and it's in order. Each element in that list is associated with an index. 2 is at index 0, 3 is at index 1, 4 is at index 2, and you can call any element from this list using its index. A linked list works a little differently. You don't have to have a specified container size in advance. You can grow the linked list as you need to grow it, as long as you reference the previous node. To traverse a linked list means to kind of, it's like a little scavenger hunt, follow the hints, follow the points and the signs. If you only have one node in the list, then your head node, the first node is always kind of referenced as the head node, is also going to be your last node, and therefore the pointer part of the node is going to be none or null, and that's how you're going to know it's the last item in the list. So the second one right here, the head always stays the same. So the head node is has some piece of data and a pointer to the next node. So this is going to point to this node, which has its own set of data and a pointer that points to nothing because it's the last node. And again, as you add nodes on to the end of the list, you go to the previous node, you find the last node, you go to the previous node, and you change its pointer to point to the new node, which has a new set of data and a pointer pointing to nothing. And that is how you add nodes to a list. So in order to traverse this list of 4 nodes, you always have to start at the head. You always need to have the head, and then the head's going to point to the next node, and the next node, and the next node, until there is no more pointer, until the pointer is empty. And then you know you're at the end. Okay, that's the brief overview of linked list. I'm going to go ahead and come down to the class that we need to finish completing. So if you read through the assignment up top, we are given the code in purple, and this purple shadow over here we can't change, that's fixed. And then right here it says define the insert function within the solution. It's going to take head and data as part of its arguments, and we're going to complete this method so that it behaves the way it needs to behave in order to pass the test within HackerRank, in order to pass the test case. So this is a very key piece of information right here. Often the challenge for me in HackerRank is understanding what are the inputs going in and how is my output supposed to look. And that can be seen if you read through the code. For example, the way this is going to be scored is using this display. So what does display do? Display, given the head, it goes through each of the nodes, prints its data, and then puts a space. So its output is just going to be a bunch of integers with spaces. And that is, not always, when you're coding normally, your output may not look like this. It may be an actual list, not just some numbers with some spaces. So this is what it needs to look like in order to pass the test. And that's the key. So coming back down here, we have some stuff that comes in from stand-in. What I like to do is copy the base code that they provide into a Jupyter notebook and create my own test case. And I'm going to do that right now, just because, I can go through this stand-in. These are each of the elements. T is 4, and then it reads in the next 4 lines coming from some information back on the HackerRank side. I'm not quite sure exactly how this interacts. You know the input. It says exactly right here. But sometimes I just find it easier to create my own test case and then put it back into HackerRank. So I'm going to do that right now. Let's go select this, stick it in a Jupyter notebook. Add a new cell. Okay, so now I have transferred all the code over to my Jupyter notebook. And I need to change this a little bit since we're not going to have stuff coming in from stand-in. I'm going to delete that and just make up some list. I'm not going to say one. Let's start with 3, 7, 9, 5, 0, 1. Just made up these are the, just like you have over here, I'm going to read in each of these integers and create a linked list with them. Head is going to start off as none, so this just indicates that the list is empty. And then for I in range T. Here I could say for data in T. And you don't even need this. For the data in T, your head, you're going to get a head after you call the insert method from the solution class named myList. Head is going to be an argument and the data is going to be an argument. And then this is some stuff that just copied over, can delete that. And then what we're going to want to do is display each element starting from the head node. Okay, let's go up here and let's code that in. HackerRank pro tip, not that I'm a pro, but I find this very helpful. Come back to the task and read it very thoroughly because everything that you need to do in order to pass is right here. So if you get stuck, just read the task again, read it carefully. Let's do that right now. So it says complete the insert function in your editor so that it creates a new node, and you're going to pass data as the node constructor argument and insert it at the tail end of the linked list referenced by the head parameter. Once the new node is added, return the reference to the head node. If the head argument passed to the insert function is null, then the initial list is empty. Okay, so that gives us a hint of how to handle that very first case what happens when your list is empty. But right here, create a new node, pass data as an argument. Okay. We are going to say new node is equal to node data. Okay. So insert is going to have data. We're going to create a new node with that data. Now when this thing is going through its first initial run, the head is going to be none. So that means this head passed in is going to be none. So if we need to create the very first node in the list, we're going to say if head is none, if the head is none, then we simply say self.head is equal to the new node. So the head is the new node. Back here, we want to, once the new node is added, return the reference to the head node. Here's our head node. Our head node is always going to be the same. We know that because if you look at this, our head node is always going to be node 0. So then we just return self.head. So that takes care of what if the list is empty and we need to assign our new node as the head node. So this assigns new node to head node. The second case is when it goes through this again, our head is now 3 and our data is 7. So how do we insert that new node? How do we append that new node to the end of the list? What we have to do is we have to traverse the list to find the last node. Right now we're going to assign our last node. So that's what we need to find. Find the last node. And we're going to set it to the head node. And then as long as our node points to something, we are going to reassign the last node until it really is the last node. While last node dot next, while there is a last node, while, as long as there is a next, if a next node exists, then we are going to reassign the last node to the next. Last node dot next. So this is going to run a loop. It's going to go through here, it's going to start here, and it's going to say, well, there is a next. If this is the pointer, while the pointer points to something, it's going to keep on reassigning the last node until there is no pointer. As soon as it runs into the last node with a null pointer, it's going to break the loop. And at that point, we can say last node dot next is equal to new node. Do you see how that works? So now all of a sudden, our last node is no longer going to be our last node. It's going to become our previous node. And our last node is going to be the new node. And again, if we remember back here, we always need to return the head. And if we read the instructions, and remind ourselves, once the new node is added, return the reference to the head node. So then we're just going to return self.head. Okay, this should work. Let's see what we get. We wanted to create a linked list with 3795, 0, and 1, and that is what we got. So I feel pretty confident now that we can just copy that, paste it back into our HackerRank, and run the code. Congratulations! All right, we were able to complete day 15, linked lists. If you have any questions, if I ran through things too quickly, if you have any suggestions for me on ways I could better present the material, I would be more than happy to hear your feedback. My whole motivation in making these videos is for me to practice talking through code. I can code all day long on my kitchen table, but that does not give me the practice I need in order to communicate how my code is functioning. So your feedback is welcome. I hope this helped you. I got stuck on this one, so if you're stuck, don't feel bad. It took me a while to figure out exactly what HackerRank needed in order to pass the test. And let's see, we're gonna do day 16 tomorrow. So if you're interested in watching me progress through the 30 days of code starting at day 15, go ahead and follow me, subscribe. Thank you, bye.